Thanks for coming. It usually gets like this, but not towards the end, but not this early. I think it's probably just because of Halloween or something last night. Everybody went out trick-or-treating or something. All right, so today we're going to talk about data processing because, well, the reason that we've been talking about strings is strings are important because they represent data. They hold data, right? And that data needs to be processed. And so there are a lot of ways that you can hold data, right? There are many data formats, and you'll be exposed to many of them throughout your careers and even in this course. XML, JSON. XML is extensible markup language. JSON is JavaScript object notation. In the TSV, this is tab separated data, right? Or the tab separated TSV, isn't it? Yeah, and CSV, right? Comma separated values, right? So that's what the V is. And what we're going to do is we're going to focus on CSV data today. I've got an example over here that represents one of the I think this is the first Discworld book by Terry Pratchett, Color of Magic, published in 1983. I pulled this data off of Goodreads. So clearly there's a title here of the book. There's the first name of the author. There's the last name of the author. There's the year it was published. And then finally, this is the Goodreads rating. All right, it's out of 5, I believe. And so what we want to do is we want to treat each one of these pieces of data separately because they're separated by a comma, right? And that's why we have CSV data. In fact, let's go ahead and call this the CSV data, right? Because it is explicitly separated by commas. You also have things like tab separated value data. Or here's another one that I was thinking about doing, but we'll stick with CSV data. I'm on the CSE system right now, and there's this file. We'll revisit this file later. The Etsy password file. This is on any Unix system, and what you can do is you can look at that and look up information about users on that system. So I looked up myself here, and it's got data about me. It's got, first of all, my login, right? This X here actually represents my password. Obviously, it's not stored there anymore. It used to be stored there in plain text or hashed or something like that, but of course that's not secure, so they moved it off into what's called a shadow file that I can't access. Nobody can access except root. There's my user ID. There is my group ID. There's my name, my office, right? My phone number, my directory, and there's my default shell. And I'm showing this to you because there's another way of representing data. How are we separating each one of these things? With a colon, right? So that's colon separated data. CSV data is most commonly is also commonly used with like Excel sheets or spreadsheets in general, where you can actually save an Excel sheet as a plain text file, usually as a CSV file. If you have a CSV file on your system and you double click it, most likely it's going to open up in Excel because Excel is going to want to process that stuff. So what are each one of these things called? Each one of these things are called a token, right? And what I want to do is I want to go through this data token by token, process that token, process that token, process that token. And I want to ignore what are called delimiters, these spaces, all right? So each piece of data, CSV, each piece of data called a token is separated by a delimiter. Right? And in this case, it's a comma. It doesn't always have to be a comma. It can be a tab. It can be a colon, as we just saw, et cetera, et cetera. All right, so CSV data, each one. What we need now is a way to process that. Right? We need a way to separate each token, right? So and process each one separately, right? All right. The operation by which we do this is called tokenization. We use tokenization to split the data up into each individual token. Right? In C, how we do this is a function called strtoke, right? Short for string tokenization. and it splits a string into separate tokens. Here is the actual function signature here. And so let's talk about each one of those things. It takes 2 arguments and it returns a value there. str, the first argument, is the string you want to tokenize. Observe. What is not in front of that string? It's a char star str. What's not there? Noticeably absent. Const, right? It lacks the const keyword. What does that tell us? What should that be screaming out to us? strtok is going to do what to it? Will change your data, right? If you do not want that to happen, then what you need to do is you need to copy that data over to another string and then process the copy instead, okay? It will change your data, so be careful. delim is the delimiter, right? It can be any number of individual characters. So for example, you can split or tokenize on commas. So you'd pass in, say, comma, right? Or, I don't know, tabs. So tab or multiple. Sorry, end it there. Oops, still not ended. Or multiple delimiters. For example, you could split it on colons and commas. So why would you want to do it on multiple delimiters? Well, there's data sometimes that uses multiple delimiters. For example, and this is why I brought up the example before, here I actually have multiple delimiters. I have colons, and then when I've got this over here, my personal information, my contact information, it switches delimiters. Is now separated by commas, right? Maybe you don't want spaces, right? You can delimit it on spaces if you want. Or if it's a tab separated values, right? You can do tabs. But it does allow more than one. We're going to stick and keep it simple. We're going to just stick with commas here, okay? What is its return type? A char star, right? So what does it return? It returns a pointer to the next available token, right? You basically call this function multiple times on the same string. Well, actually, multiple times. Let me erase that. Multiple times until the last token is given, right? ... So how do you know when you're done? Right. Well, again, let's take a look at the signature here, right? It returns a pointer. So here's the first token. I'm pointing to it now. Here's the second token, the third token, the fourth token, right? And then there's no fifth token. What can I return to indicate that there's no token there? What's the only value that can be substituted for a pointer that we know something went wrong? Null, exactly. So it returns null when it's done. It returns null when no more tokens are available. Excellent. All right. So be careful here. The first time you call it on a string, you pass in str, the string you want to tokenize. Each subsequent call, pass in null for str to continue processing the same string, right? Because if you give it another string or the same string, it'll just process that new string, right? It keeps track of the memory address that you last tokenized in order to give you the next token, right? So now that I've explained all that, let's actually see it in action over here. I've got that same CSV data, and what I want to do is I want to process this token by token. Now, by processing, I just simply mean I'm going to print it out, right? Of course, you can do more complex stuff later on. We're not there yet. I just want to print it out to see that it's actually working, right? So let's go ahead and call strtok. Right? Remember that I've already included, oh, no, I have not already included. What do I need to include if I'm going to be doing string stuff? The string library. That's where it's located. String.h. There we go. So we will call strtoke on CSV data, right? And I'm going to pass in the delimiter that I want here, the comma, okay? And we need a return value here, char star, and I'll call it token, right? Because that's what it is. Now let's print it out to see that that's working, all right? So the token is equal to %s and the line token, all right? GCC demo. So what's the first token here? Just the title of the book, Color of Magic, all right? What if I did that again? Right? I can't have the same variable there, so I'll go ahead and use this instead. There we go. Right? And GCC, A.out. Still the color of magic. Remember, the idea here is that you pass in the string on the first call. Every subsequent call, you pass in null instead, because you want it processing the same string, the CSV data over here. If I had it like I had before, where it was CSV data, that means, okay, that means this thing over here, that means I'll start at the beginning of the string again. Right? And that's why I get the same token over and over and over again. Right? So pass in null here, and you will get the second token, right? Terry. All right, well, what I could do now is I could copy, paste, copy, paste, copy, paste. Right? And if I know exactly how many tokens there are, that might be a good idea. Right? Color of Magic, Terry Pratchett, 1983, 3.98, null. What happened on that last call there? It returned null, because is there any more data after that 3.98? Nope. So maybe a better way of doing this would be a loop. Right? In fact, now if you know how many tokens you have up front, a for loop would be appropriate, but I'm going to go into a while loop here. While the token is not equal to null, that means I've got a token to process here. The processing will simply be just me printing it out, and then to set myself up for the next iteration of this while loop, I will go ahead and call token again. And that relieves me of the need of having to copy paste a bunch of code there. Right? Now we don't get null at the end. Why? Because once it's null, we've broken out of this loop, we don't end up processing it right here. Okay? All right, great. How do we do that in Java? Actually, before we do that, let's go ahead and visualize this. It's worth it to visualize, because I want you to observe a couple of things here. We're probably going to have to include the string library. There we go. Oops. All right. And I will have the same code as before. Let's visualize this. Oh, include. There. There we go. All right, so we've got our CSV data there. Notice there that it is a full single string with one null terminating character at the end. Right? Now we're going to call strtoke. Did you see the change that happened? Look at index 15, right? At the end of Color of Magic. So watch this over here, the first delimiter. What happens to it? Null. It's the null terminating character. That's how it works. It gives me a pointer to this first token here, and then to make it a valid null terminated string, it replaces that delimiter with the null terminating character. This is why we didn't have a const in front of the string, because it will change your string. Right? All right, we print that out. And what happens when we call a token next? Right? It's going to be Terry, and what do you think is going to happen to this delimiter here on index 21? It's now the null terminating character, and our pointer has advanced to Terry now. Right? And so if we can continue to go through this, Terry Pratchett, 1983, 3.98, right? You see that it has changed 3.98 here, and then it hit that last null terminating character. Right? That's why it returns null when it's done. Okay? All right, good visualization there. How do we do this over in Java? Pretty much the only thing that I'm going to keep here is the actual string data, CSV data. There we go. I don't need this at all, right? Because I don't have pointers. I don't have null terminated characters. I don't have a lot of the stuff that C has. So instead, what I'm going to use is going to be CSV data dot split. And you want to split, this is why I was using that terminology, either tokenize or split, because in Java, we split it. How are you going to split it? I want to split it along, slice it, split it along that delimiter right there. All right. Now, what does that give us? Let's go ahead and RTM. There is a return value here. It is a string array. Or let me call it tokens, because that's what it is. Right, there we go. Now what we can do is we can iterate through that array of strings, and each one of them will be a token. The easiest way to do this is a traditional, not a traditional for loop, but an enhanced for loop. So string token in the collection tokens, system.out.println token, excuse me. Right. There, Color of Magic, Terry Pratchett, 1983. 3.98. Okay. It splits it out into an array of strings for us. Kind of like what you're going to do when you do length split, right? And length split will not work on this because this is taking a delimiter, but it's the same idea, okay? And there might be a way that you can do that with a simple one-liner or not, but yeah, I mean, not a one-liner, but you can definitely leverage the string library stuff in Java to make that way easier than it would be in C. Okay. What if we use different delimiters? Let's experiment. What if I wanted instead, I don't know, a space? What's going to happen now? What's that? What's the first token? Color, right? Uh-oh, of magic? It's the same stuff afterwards. My first call was on a space, but what was my second call? On a comma. So be consistent about it. Right? And you'll get something like this. Color of magic, and were there any spaces left after that? So that entire thing ends up being a space right there. Okay? All right, what if I did it on multiple delimiters? Say commas and spaces, and maybe lowercase a's. GCC this, and what will I get out of this now? Whole bunch of gobbledygook, but whatever. Color of magic, because A is a delimiter. Terry Pratchett, the A there is a delimiter, right? And then the rest of it is just normal. Right? You can do as many delimiters as you want here. Right? I'm going to go ahead and take it back to normal here for when you actually put this into the notes here. There we go. All right, so careful. Do not do anything directly with the tokens. Right? So what I mean by that, if you need to process it as a number, fine. Use A to I, or what's the other one? A to F, right? If you need to leave it as a string, make a deep copy. Right? Because what happens? You're taking this, all this token is a pointer to a string, right? So for example, if I had token 1, let's go ahead and unroll this this while loop here entirely. Right? There we go. Token 2, 3, 4, 5. Right? 2, 3, 4, and 5. Right? And then let's make this null. We'll make this null, make this null, make this null. Now, are those actually strings that are being stored somewhere? Not, I mean, yes, technically. Let's go ahead and get rid of this. Edit this. But what ends up happening here is, do I need the data again? Okay, no. There, go ahead and get rid of that. Right. Those are not deep copied strings. those are just those just end up being pointers to various parts in your in the original string. And if the original string is lost somehow, right, then these pointers will end up being lost. What I mean by that is, what if we were to free that up, right? Okay, we've got all our tokens, right? What I can do now is I can reset it, CSV data, strcpy into CSV data. Hello world. There we go. What have I done to all my tokens now? Yeah, they're all corrupted now, right? Watch. This is edit this code over here. All right, let's go ahead and copy into that CSV data, hello world, and let's see the consequences of that. Visualize this execution. And come on, there we go. Dot, 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 dot. Pointer, pointer, pointer. Uh-oh. Hello world is in there now. Tell me about this pointer. Yes, it still points to Terry, but what about this pointer? It points now to hello world instead of color of magic, right? So if you need to treat them as separate strings, you need to make deep copies of those strings. Just as a really quick reminder here, let's go ahead and do that, right? Let's create an array of, I don't know, char star star token data, right? This is a good exercise. We want to create an array and to hold deep copies of each one of these tokens, right? So char star, right? Call to malloc, right? And how many of these should I have? Size of char star. How many tokens am I going to have in this case? 1, 2, 3, 4, 5. So I could hard code this to 5, and for this demonstration, it would absolutely work. What if I had different CSV data though, and I didn't know up front how many tokens there are? What could I do? A counter. I could iterate over every single character, or okay, so let's go ahead and do that. For int I equals 0, I is less than strlen of CSV data, I++. What do you want to count? You want to count the number of tokens, yes, ultimately. But what tells you that this is a token, that's not a token?
It's a comma.
Okay, it's a comma. If CSV data sub I is equal to a comma, or right, in this case, if we had a different delimiter, of course, we would change this code. Then I can say count plus plus, which means I need that as a variable. Int count is equal to 0, right? There. Now, at the end of that loop, what have I actually counted? Have I counted the number of actual tokens? Color of Magic, Terry Pratchett, 1983, 3.585. That's what I want. But what am I actually counting? Number of commas. So what should I do? Count. There were only 4 commas, right? But I want 5 out of that, so plus plus. Something like that. All right? Of course, this is still a little bit brittle, but that's all right. All right? So there, now I've got my token data stored in, or I've got my pointer to an array of pointers. Now I need to make each pointer point to a string, right? So I will go into my for loop here for int I equals 0, I is less than count I++. I know that there are going to be 5 tokens here. So token data, right, sub I, what I want to do is I want to copy the current token into token data sub I. Well, first of all, I need to, of course, get this, right? And I'll do that outside temp. I'll call this temp token. Right? So that's the token that's pointing in the original data. Okay. And I'm going to update that every single time by calling temp token at the end of this. Temp token is equal to strtoke of null with the same delimiter here. The reason I did this outside of the for loop is because the first time you need to call it with the actual string. Each subsequent time you have to call it with the null value there. All right, so can I do this? Temp token. There we go. What kind of copy is that? A shallow copy. That's not what I want. That's what I had before. This is no better. So how do we do a deep copy? Okay. str copy, that thing that I wrote already, right? But I've now erased it. So how do we do that again? Char, or call to char star malloc. Right? I want to do this manually anyway to get more practice, right? But once you've written something and you've put it into a function, absolutely use those functions, right? Think function reuse going forward. All right, this is going to be size of char times strlen of the temp token. Be careful, HELLO or TERRY, Terry, that's going to be 5. I want, what else? +1 for the null terminating character. And make sure that your math is good there. Now I can go strcpy into token data sub I, temp token, and move on to the next token. All right, I don't need all of this stuff now. All right, there we go. Actually, I'll leave that last one in there that screwed it up, so that when we go to visualize this, you'll see that it actually did work. All right, so for let's make sure that it worked by simply just printing it out. For int I equals 0, I is less than count I plus plus. Right? Printf token tokens token data. So %d is equal to %s and the line. There we go. And token data sub I. There. GC, see this? Uh-oh. Oh, token data sub I also need I. There we go. There. A dot out. There. Color of Magic, Terry Pratchett, 1983, 3.98. And this change at the end here will not screw up any of my tokens. Let's observe in this visualization here. Edit this one more time, and then we'll move on back to Java. Maybe quit for the day, I don't know. You can do more exercises if you want, but nobody feels like showing up. Maybe I shouldn't show up either. No, I will, don't worry about it. And I'm not ragging on any of you that didn't show up. That's fine too. That's why I do this. Right? Okay. In fact, this is better than what it was during COVID. There would be like one person showing up in a lecture hall of 250 people or something. All right, so yeah, count. Uh-oh. Oh, I don't want to do this. I can't advance. Okay, let's see if I can advance at least to that. So that, to that. Okay, there we go. Finally. All right. I don't want to. There's no way to set a breakpoint here, unfortunately. But I got the correct count there. There are 5 tokens there, and then as this tokenizes, you'll see that. Oh no, where's my? Oh, okay, it's way over here. There we go. Color of Magic, right, has already been copied. I'm going to advance this a couple more times, see, so I can go over here. Color of Magic, Terry Pratchett. These are all completely separate from my original CSV data over here. So next. I. There we go. All right, and we've broken out of the loop at this point, and we're about to copy. Or no, we guess we're just printing them out there, and we're about to copy into the original CSV data hello world there, right? But all of my tokens are preserved over here. Nice. All right, so I'll go ahead and make sure that you've got this in the notes as another example if you want to. But otherwise, that hopefully will give you some hints there if you're struggling with the length split function that you're using right now. Because that's basically the length split function with more steps, right? So what, by using this tokenization idea here. Now let's come back over here to Java. Do I have that same issue here? Did it change the other string? No, why? Java strings are immutable. It can't be changed. Right? This original string up here is still the same. System.out.println CSV data. Right? Wonderful. I don't have that same problem. In fact, if I were to debug this, let's go ahead and put a breakpoint in there, you'll see that it basically did all, that entire demonstration that I just took 10 minutes to show you, it basically did that automatically over here in Java, right? Because it's that it has to, right? Step, right? There we go. Over here, unfortunately, I can't zoom in. Here, I don't need to zoom in. There's the tokens, right? 0, 1, 2, 3, 4, right? The 5 tokens there. They're all completely separate strings, right? It basically did all of that fancy stuff that I just did, memory management, all that stuff automatically over here in Java. Right? Okay. One thing, however, that I do want to cover in Java before we leave here is this is not actually, I mean, the way that I'm using it is it's a single delimiter, a single character delimiter. It doesn't have to be that way. What I want to do is maybe I want you to split on any lowercase letter there, A through Z. Hopefully this will work. Let's find out. Yep, it did. Let me go ahead and get rid of this and so that we can see it a little bit better. Oops. There we go. All right. So actually, that's not as interesting. There's a bunch of blank space there. Let's go any uppercase letter, A through Z. There. Why do I get those tokens? Well, what's the first token here? Capital C. What came before it? Nothing. So therefore, it was an empty token. You can have empty tokens. Multiple empty tokens at the end are treated as one token, but multiple tokens inside of the string are treated as individual tokens. Then I have color Euler of space, right? And then I see my next capital letter there. My next capital letter, right? T, et cetera, et cetera. Now, what the heck is this thing, and why is it so powerful, right? That is a regular expression. In fact, let's go ahead and go over here to regular expression debugger online. I forget what it was. regex 101 is what I was thinking of there. Regular expressions are, have we talked about that before? I think I've hinted at it before, maybe not. I forget. But anyway, test string here. Let's get some lorem ipsum text generator. I need some text to work with here first. There we go. If you've never heard of that idea before, this is used all over the place. It's just Latin so that you know that it should not be there because it's nonsense. And it's also, even in Latin, it's nonsense. And it's just a placeholder that it gives you some data to work with. Visual artists do this all the time. They'll put in lorem ipsum text, and then they're waiting on the person to write the actual script to replace that lorem ipsum text. All right, so I want to match any uppercase letter, A through Z. Right? There we go. It will match only the capital L. I don't know if you can see this really easily or not. It's matching the capital L. It's matching the capital D there, et cetera, et cetera. This is a regular expression. It is a grouping, A through Z. You don't have to go through A through Z. You could say A, B, and C. Right? That is saying match the capital letter A, match the capital letter B, or match the capital letter C. It's a disjunction, any one of those things. Now, obviously, there's no capital letter A, B, or C in here, but if I put one in there, A, apple, banana, and what's another fruit that starts with a C? All right, cauliflower. I don't know how to spell it. Right, there we go. Now what's it matching? That A, B, and C. Right? This is extremely powerful. You can do A through Q instead of A through Z. Right? You could do lowercase a through Z. Right? I want to find all words that are all lowercase, A through Z, but that are only 3 letters. 1, 2, 3. Right? And now that's going to match any sequence of 3 letters, but if I want it to be an individual word, put a space after it. Put a space in front of it. What did that highlight there? Every single 3-letter word. Right? What if I wanted to find something that looked like a phone number? 0 through 9. Right? 1, 2, 3, followed by a hyphen there. 1, 2, 3, 4. Right? and 402, 472, 5001. Hey, what did it just match? That phone number right there, right? These are super powerful, right? And here's some primitives for it. Period matches anything, right? So every single thing was just matched there. You can have what's called a clean star at the end. That will match any, this is one individual character. This is matching each individual character individually. By putting a star there, I'm matching the entire thing. Right? So you can use this in conjunction with other things. For example, 0 through 9, say 9, sorry. 3 times, 1, 2, 3. Followed by anything and preceding anything. Right? And now what is it doing? It's matching everything here because it's matching these, this sequence of 3 numbers and this sequence of 3 numbers and this sequence of 3 numbers. Okay. What else? Basically, I'm not here to teach you regular expressions. I'm here to teach you that they exist and that they're super powerful. And with a few small expressions, you can do really, really powerful stuff. Match anything that looks like an email, for example, right? What would it be? A through Z, capital A through Z, 0 through 9, right? With an at, and then the same thing, dot star. Let's just simplify it like that, right? So, you know, something that looks like an email. It's actually going to be way more complicated than that, but that's the idea. Right? White space, or hit with space, that'll hit every single space. But what if I have tabs in there? Oops, I want to tab. How do I tab in there? I can't tab because it's tabbing along my, I need a, all right, so let's copy this, bring it over here temporarily. There we go. Now let's go ahead and add in an inline character. Let's add in a tab and copy and paste this back over here. There we go. All right. So that space that I put up there, right, it's only matching actual spaces. Right? What about an inline character? Right? What about that tab character? What about any white space character at all? I think it's B. Right? There we go. That will actually match all the white space there. Right? Let's take that back over, and then yeah, let's go ahead and take that back over here, and let's split that based not on that, but based on the white space characters. Now, there are 2 backslashes there. That's because that's a special character in a regular expression. But tell me about that backslash. That's also a special character, so I need to escape it. And that's why I've got 2 backslashes there. Now, I only have 2 spaces there. Right. Oops. It should be... why is it getting me that? There shouldn't be other spaces in there. I think it's B. Maybe it's this. There's a trick in Java. Nope, that's not right. Star. Yeah. Nope, that's everything. So I'm going to have to look this up now. Java, regular expression, white space. I thought it was B, but maybe it's not. S. Okay. By the way, there are different dialects of regular expressions. What we were using over here was Perl compatible regular expression version 2. This is Perl compatible regular expression Python. There. If we had been using the Java 8 regular expression over here, then it would have been different. So it's actually S. Sorry. There. Now that will split just like before along those 2 spaces. But what if I had tab characters in there? What if I had inline characters and a space after that? Let's see what's split now. Right. There we go. There's that tab character, and so we get COL. Right. What about these 3? Actually, what about these 2 empty tokens right here? Where do those come in? Yeah, those new line characters. 1 new line character, 2 new line characters, and a space. I don't want that. I don't want the empty ones. So what I can do is I can modify this and put a star there. Any number of white space characters. Right? And what happens to those 3? They get collapsed into 1 token. and I don't have those empty tokens anymore. Ah, come on. All right. It shouldn't be that. It should be, I think maybe like this, because Java is different. Yeah, Java. No, that's still doing it, so I need a star there now. That should be it. Nope. Darn it. All right. Any number of. Oops. Nope. All right. So what is the SS and then? All right. They're getting into really esoteric stuff there. All that stuff is considered white space characters, which are a bunch of Unicode characters. No, that's just a single space. And wow, great. Terrible answers here. All right, I'm not going to be able to do it. I'm going to have to look it up later. But you can do it. If you want to, oh, maybe it's because I screwed it up somehow. But anyway, there is a single space character. If you wanted to double this up, then it would split along. Oh, no, I don't want that many. There we go. That's 2 white space characters there, and so I'll get completely different behavior. If it's 3 white space characters, there we go, then I'll finally get that one and only token right there, because it's matching 3 white space characters. So the takeaway from this demonstration is these regular expressions exist. You should eventually learn them, because they are super, super useful. Right? Now, I myself am not a regular expression guru. I can write basic regular expressions, but if I had to do some complex task with regular expressions, I'm of course pulling out my manual and reading it because I don't remember everything. But once you've got that regular expression, right, just investing that a little bit of time to remind yourself of how you do this and how you do that, write a regular expression over 5 or 10 minutes, it's going to save you 15 hours of data manipulation stuff, right? Just let it do it for you. Just yesterday, right? I had to take a bunch of student names: Chris, Burke, Joe, Maurer, Anthony, Rizzo. All right, some weirdo, not me, and I don't want to call them out as an actual weirdo, but who does data like that? Who keeps first name, last name? No, it should be in 2 different columns, and it should be the last name, comma, first name, right? And so can we do regular replacements here? I don't know if we can do replacements here, but I can do something else. Nope. So new window. There we go. All right, so, all right, let me go ahead and get those names there. Now what I can do is I can do a find and replace using regular expressions. All right, I want to match any characters A through Z, or A through Z, A through Z, there we go, or capital A through Z, followed by a space, right, followed by the same thing. There we go. All right. Oh, and then I need stars, sorry, because 1 or more. And unfortunately, there's no way to make this bigger. All right, what I've done is basically I've said match the first name, match the last name. Now what I can do is I can, those parentheses there are what are called groupings. What it does is it says, remember this token, remember this token. And then I can do some magic here. The second token, print that one first. Then print a comma and a space. Then print the first token. Right? And here, let's get that out of the way. And let's replace them all. Hey. Cool, right? Why? Did I have to go through and pull out this first, like, what if there were 1 million student records here? Are you going to be doing that? No, or you could write a program that reads the file in, processes it token by token, outputs a new file that's much better with the last name, comma, first name. Or you can learn a regular expression here and get it done in 5 seconds, right? So which one are you going to do? Hopefully you can learn some regular expressions. Again, I always get data from other people, colleagues or a college or a university or whatever, and nobody has any good data management. They always give me these garbage Excel sheets with the first names and the middle names and the last names, and there's no distinction between any of them, and it's extremely difficult to process, or they give me just one big giant file, a text file with no delimiters at all. So my solution is to open it up in my favorite text editor, start writing some regular expressions, clean up the data, and get it into a form that I want. Right? And if you know regular expressions, if you know computing, you will save thousands and thousands of man hours. We have business folks doing all this kind of stuff and then manually changing stuff all the time. When if they had just learned some regular expressions, we wouldn't need so many business people in the world. Nothing against business people, but whatever. All right, that's where we'll stop it for the day. All right, well, have a good weekend.